Morning. This is Y. Suresh, lecturer in mechanical engineering, KP Government Polytechnic, Hyderabad. I would like to explain about subject is solid mechanics. In that, major unit, or you can call it as content, unit is simple stresses and strain. In that, subtopic is introduction of solid mechanics, whereas types of materials, loads, and types of loads. Okay. First, introduction. Okay. These engineering materials, you can see here how they are behaving with application of load, whether they will withstand with the load or break it or thinking. That means in previous years you can study about only application of forces. That means you can study about kinematics and kinetics only. There you can assume that the materials or any member is called as rigid body, rigid materials. Here we can study the application of materials also. That means what will affect the application of load. Okay, in this you can see here. Now, in this content of this lesson, e-lessons, you can complete after completion of this class, you can be able to understand what are the engineering materials and also different types of engineering materials and what are the forces, external forces are using and also different types of loads. First, material. Material is a synonym with substance and is anything made of matter. That means it's made of matter, you can call it as a material. The term material is used more narrowly to refer substance or components with certain physical properties. Materials are the substances which contain certain matter. Engineering material. Materials are used in engineering applications. You can call it as engineering materials. There's all the materials mostly you can use in all the engineering applications. You can see here structure of multi-story building. In there so many it is a composition of so many materials. Okay, steel, wood, plastic, glass or anything. In aircraft also, aircraft is made up of so many material, lightweight material, spacecraft also is made of lightweight and also as well as heat resistance materials are required in missiles also like that, in components of machine tools also. Where these are the different components we are using all the materials in engineering field. Now, generally broadly classified classification of materials are generally classified into two types. First, metal and its alloys. Example, iron, copper, aluminum, steel, and etc. And second one is non-metals. That means wood, glass, rubber, plastics, etc. Here I am giving showing some of the examples here. Copper doors and copper tubes also, gold, cooking utensils made of copper and what we call bronze making. Next, also iron doors, wood components, plastics. Now, these materials you can call it as two types. First one is material. In that materials you can classify two types mainly, not two types. Another one is also there, three types. First one is elastic material. Second one is plastic materials. Third one is rigid materials. First, we can let's explain about what is rigid material. Sorry, elastic material. When regain their original shape after deformation, when external load is removed. Second one is plastic materials. Undergo continuous deformation, they will not regain their original shape after deformation when the external load is removed. Rigid materials does not undergo any deformation under the influence of external forces. In the universe, no material is neither elastic, pure, nor plastic, nor rigid. Now, strength of materials deals with the behavior of bodies under the action of external loads. The deformation under the load is of major interest. To find out whether or not a given member fails under the load. That means whether the using member or any component, whether withstand with application of load, whether it will withstand or fail, it won't take the load. An external force acting on the body is called as load. External forces are classified into first one dead weight, frictional forces, inertial forces, centrifugal forces. First, dead weight. Weight not in motion. Example, hanging the crane. Load hanging in the crane, which is called as example, load, dead weight. Frictional forces. These are generated, applied due to frictional forces are due to relative motion between two parts or more parts. Inertia forces due to rate of change of momentum. Example, reciprocating parts of an engine. Example, another example, piston, crankshaft, connecting rod. All are coming under inertia forces due to inertia forces only. Next, centrifugal forces. These are due to getting the forces due to rotation, cranks, pulleys, flywheels, etc. Next, major loads or major classified is according to manner of application. Second one is according to nature of application. Third one is according to effect produced. First, according to the type or manner of application. First one is point load. Load acting over a small area is considered as point or concentrated load. It is expressed in newtons or kilonewtons. Here you can see here, this is a beam having the load is applied at a point. That means you can call it as point load or concentrated load. Next is distributed load. Load distributed over an area or along the length is called distributed load. The load may be uniformly or non-uniformly distributed along the length or over an area. It is expressed in Newton per meter square or Newton per mm. Hence here the load is applied throughout. You can call it as uniformly distributed load. Here load is varying continuously. Let's say non-uniformly distributed. Next, according to the nature of application. First one is static load. Increase the load from 0 to certain value and remain constant during entire time of their application. That means increase from 0 to certain value and remains constant. The example is self weight of the machine element. Second one is dynamic load. Refers to the impact or falling load in which the duration is very small, or you can call it as fraction of second. A good example is hammer blow on a nail. Third one is fluctuation or cyclic load. If the magnitude direction varies continuously, that means one time it is you say you cancel another time. Yeah. Once again it is repetition, you can go it as compressive. Example is troughing crossing the bridge. Next one is the according to the effect produced and the load action of the load and the load. When the load is how we are getting when a load is applied. First one is tensile load. If the action of load is to increase the length of the structural member, then the applied load you can call it as tensile load. Once again, I am repeating here. If the action of load is to increase the length of the structural member, then the applied load is called as tensile load. Next, compressive load. If the action of axial load is to shorten the length of member, then the member is said to be in compression and the applied load is called as compressive load. See here, this is your member, the load is applied on this one. That means it is shorten the member, that we can call it as compressive load. Next is shear load. The load acts perpendicular to the axis of structural member. It tends to slide with respect to other or cut the part. That means load is applied perpendicularly. See here, load is applying here perpendicular. It may shear here or you can break it also. Next is torsional load. The load which tends to twist the member. You see here unscrewing or unscrewing of the nut and bolts. Next is bending. It travels load to bend the structural member. Okay. Here I am giving the small animation videos you can better understand. Okay. What are the types of loads? See here. You can see here types of loads. Steady or dead load. If the bridge element do not change with time, neither increase or nor decrease the size or weight. It neither shift or nor move from their original position because these are the structural ones. So that is you can call it as steady or dead load. A load is said to be steady. Next is variable load. That means it is changing its plan. Example, now you can see here a bus is coming, bus is boarding the passengers. If the number of passengers getting into the bus is more, then the load will be more. If the less passengers there is less. Next one is shock load. See here when the load is applying on weighing machine or placing on the sawing machine. To keep it at as weight is once removing it is going to give zero value. Now traveling a car here, applying brakes, suddenly we can go for, we will observe the feeling of shocks. But in order to less these shocks, we are using suspension. That is called as suspension. We can shock absorbers only. Next is impact load. You can see here he's taking hammer and blow it. You want to change the shape. You can see here in daily life, you can roadside also. You can use it this found forging, converting into from change its shape from in hot what you call hot condition only. That means you can first you heat it the component and change it into according to your manner, whatever the required manner. Okay. Okay, this is one video. Next is See here, we can see here. Observing in the table also can have metals, non-metals. You can see here table, book, calculator, or mobile and computer. So these are made of different materials. Ornaments made of generally metals, gold, copper, or anything, platinum, also gold, silver, bronze. Next is cooking utensils. Metals have their most important is shining with respect to one. Next is sewing, cooking utensils, different machines are on generally. Gold plate, copper sheet, zinc sheet, aluminum sheet. Metal can be beaten into sheets. That means not beyond metal can drawn into sheets. Call as it is proper texture. We can discuss later, or you can call it as malleability. Metals can drawn into wires. You can call it as ductility. Next class we can discuss here. Yes. See here, a rubber band we are applying forces. It will be extended. The spring also stretchable. When forces applying, it will be elongated. Reforming forces. See here, once the force is applying, it changes direction. Ability to regain original shape and the applied force is removed is called as elasticity. See here, taking the spring and applying force more and more, it automatically breaks. You can call it as permanent deformation. Object cannot attain or partially attains its original shape once the applied force is removed is called as opacity. So far now in this class we discussed about engineering materials. That means what are the materials we are using in engineering field, we can call it as engineering materials and also applications. They are using so many wide areas. That means multi-story building, aircraft, missiles, spacecraft, and mission components. Next is different types of engineering materials. That means the materials may be classified as rigid materials and plastic materials. Next is forces, static force, dynamic force, and also inertia force, torsional forces. Okay, these are forces and also types of loads. Concentrated load, point load, concentrated load, distributed load, shear loads. Okay, these are the see here the material which regain its shape in these small questions. And the material which regains its original shape and size after removal of the external load is known as called as regain it's called as elastic material. The load which tends to twist the member is called as torsional load. So here some of the important questions here list out the engineering materials and describe any two. And also another question list out the types of loads, describe any two in its sketch. So that's it.